if you are looking for the value of the constant n, and they told you the coefficient of x is 7, you understand, at the end of the day, if you're trying to look for one missing number over here, which is what's happening, you're looking for one missing number, you need one equation involving that missing number. And it's very obvious over here that this is the only information they give to you that you can turn into an equation to get that missing number. In that sense, you'd realize, this is what they're expecting you to know in order to start this question. If you have 3 minus 2x, what we're doing right now is we're explaining to you, you actually know what's up, like what even happens over here. You have to understand that if you have 3 minus 2x times anything to the power of, let's just say hypothetically, we're not saying n is 3, but we're saying if n were 3, understand what happens over here, it's going to be 3 multiplied with everything over here. So if we were to write this out, whatever that to the power of 3 is, has a bunch of terms, doesn't it? Like this, like something number plus something number x, plus something number x squared, plus something number x cubed. That's literally the definition of what this is. And it's going to be equal to what? 3 multiplied by that entire bracket over there, isn't it? Minus 2x multiplied by that entire bracket over there. Remember the definition? Because if you have two things inside a bracket over there and another bracket, it's going to be the first thing times the second bracket minus 2x over here times the second bracket. And what happens over here is 3 is individually multiplied with every single term in there, isn't it? Minus 2x is individually multiplied with every single term in there. As in all of this just gets copied down. All of this just gets copied down. So the number term over there plus the number term x. You understand this general concept over there. 3 gets multiplied with everything there. So whatever power that is going to be. Now my point is this. Depending on whatever your n value is, do we really care about 3 multiplied with every single thing in there? Or do we only care about 3 multiplied with whatever inside of here, after fully simplifying, gives you a coefficient of x? As in, we only care about 3 multiplied with what inside of here overall will give you x. We only care about minus 2x multiplied with everything inside of here overall that will give us x. This is just basics of binomial expansion over here. So without further ado, you'd realize it's going to be 3 multiplied with whatever inside of here is going to create overall one of the x's. And you remember this rule? They're expecting you to know. For this question, for binomial questions, you know that every single unique power comes from a set of triple brackets multiplied together. So for this over here, the set of triple brackets, remember they always start off the same way. It always starts off as whatever the n value is over there, whatever the first term is over here, whatever the second term is over here, like this. And it's up to you to decide what the powers are going to be. The reason why we wrote the power over here as 1 is because we know for a fact, in order to create a coefficient of x from this multiplied with 3, this overall has to create 1x, x to the power of 1, which means x over here must be to the power of 1, because these don't affect the x power, do they? Do they? So we know that this is going to be 1, and remember the rule, they're expecting to remember the rule for binomial expansion for the triple brackets is that this is a 1, this must also be a 1. And this must be added together to give you n, which is n minus 1 then, isn't it? And you realize over here, remember the essence of algebra over here. It doesn't matter what algebra scenario you're dealing with, you always prefer the more simple version of something. In math, same way you're writing math as a language, because math is languages at the end of the day, you don't do double positives in language, do you? You don't really overlap any of this. Meaning n1 over here, is there a better way of writing that? Yeah, there is. n1 just means nc1. Any number c1, type in 6c1, 5c1, 3c1. 3c1 is 3, 5c1 is 5, 6c1 is 6. So nc1, we can see how it's represented with n, so it's 3 times n times 1 to the power of n minus 1, we realize is the exact same thing as 1, isn't it? So we just don't need to include that. That's what they're testing us on. Times by x over 2, which is 3n times by x over 2, which we know becomes 3nx over 2, which we know from algebra we can take out like this. It makes it really obvious that this is the coefficient of x. This is the coefficient of x. So we have that, and we know that minus 2x, same principle over here, isn't it? What's going to create the overall coefficient of x? Minus 2x multiplied with what inside of here? That unique power we're looking for multiplied with x is going to be the thing that doesn't have an x anymore, isn't it? It's going to be x to the power of 0. And we know x to the power of 0, just like any unique power over here, comes from a set of triple brackets, which starts off as n, 1, and x over 2. Okay, this is the a and b part, isn't it, from the basics? If you're not sure about this, go back to the basics. This is just assuming you know the basics over here for binomial expansion. So it starts off as n1 and x over 2. We know this has to be 0. If this is 0, this has to correspond with 0. This has to be n like that. nc0, if you're not sure what nc0 is, first off, you have to realize nc0 can be represented with something a lot easier. Otherwise, this question wouldn't go anywhere. You get my point? Like, this question would have come to a stop if you didn't realize what nc0 can be represented as. Or if you didn't even know what this really is. This is really the same thing as nc0, isn't it? Why? Because remember, if you're confused, if it's 6c0 over here, you know it just means 6c0, right? So it doesn't change the fact that if it's n0 over here, it just means nc0. Type on your calculator, 6c0. 10c0, you get the point, it just gives you 1. 1 to the power of n is 1. We don't do double positives in language, just like in math over here, we don't do 1 times 1 to the power of, no, it's just, if it's 1, ignore it. Like, we omit it, because it doesnn change the answer. Anything to the power of 0 is just 1. So that's where you get negative 2x. we're realizing that when we expand this whole thing, 3 times everything here and minus 2x times everything here, which is what expanding the whole thing is, and then group together and simplify, overall, for the x coefficient over here, for the x term, we'd end up having this thing combined with this thing, isn't it? Which we realize 3n over 2x minus 2x is the same thing as, the same way if you have 2x minus 4x, it's going to be negative 2x. Why is it the case? Because we just added these together like that, isn't it? So wouldn't it be the same thing as adding these? It's my basic logic over here. That's why we did these two combined together, gives you this. And we can make that equal to 7. How did you come across this logic? Do you see how it's the very, very simple understanding from the beginning that you had to find some sort of equation involving x, coefficient of x equals to 7, some sort of equation that contains your missing number n. Isn't that what we did over here? Do you see all that work we did was really just to get this? A simple equation involving n equaling 7. Just taking that information they give to us. Because this is literally what it is, isn't it? We took this information and turned it into this, which is something that allows us to find what the missing number n is. We do the basic algebra here for n is equal to 6. And then, of course, if n equals to 6, you don't need to be told to replace the n over here with 6. So you go ahead and do that. That's n equals to 6. And then it's going to be 3 times everything inside of here, minus 2x times everything inside of here. But do we really want 3 multiplied with everything fully expanded and simplified? Fuck no. We don't want to do that. We just want to do 3 multiplied with everything inside of here. That would create x squared, which is the thing inside of here that gives you x squared, isn't it? Which is what we did over here. And it starts off the same way, doesn't it? Set of triple brackets. Every unique power is a triple brackets. Bracket, 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 6, 1, x over 2. Why do we only write these? Because it starts off the same way. It always starts off as n over here, a over here, b over here. A, b, right? A plus b to the power of n, like this. Anyways, how do we know which one to write first? We wrote 2 over here first, because it's the only thing that has an x. We need to guarantee we get an x squared when we multiply with 3. That's why this has to be a 2, and if this is a 2, this has to be a 2, and this has to be a 1. This can be evaluated 6c2 times 1 times x squared over 2 gives you 15. 15 times 3 is 45, and that's how we get this number. Just like over here, it's going to be minus 2x. We only care about minus 2x multiplied with whatever inside of here is going to give us x squared overall, which means inside of here, it's the thing that gives us x. Minus 2x times whatever inside of here gives us x, which is minus 2x times something x over here. What is the x in here going to be? We realize it comes from set of triple brackets again. And that's why we do set of triple brackets. And the set of triple brackets always begins the same way, same principle, x over 2. Now, if this is going to be 1, why do we think that's a 1? Because this being 1 is going to create overall 1 of the x's, x to the power 1, which times by minus 2x gives us x squared, which is what we're after, isn't it? So this is the 1, this is the 1, this has to be a 5, and then simplify this, multiply that all together, times it by 6, and you're going to get minus 6. And you get that these two combined together, it's just going to be 45 over 4 minus 6, which is 5.25. N is 6, coefficient of x squared is 5.25.